Okay, right, so the stream's intact, so things are being recorded, so just mind your volume. All right, so folks, we started looking at circle geometry last week, Monday, and we said the topic is very, very visual based. You have to remember the rules, and the rules are based on diagrams, specifically diagrams with circles, hence the name of the topic, circle geometry or circle theorem. All right, so we had a couple, and we have a few more to add, right? So there's a, I'll give you a little piece of it, right? So there's this rule which takes into consideration two tangents to a circle. All right, hold on. But before we get there, we want to explore one tangent to a circle. So that will be the crux of today's class. If we get a little chance, a little time at the end, I'll introduce you all to the stuff for next class. Nah, today is just drawing. All the other stuff is from an exercise I had to do. So today is just, you can do quick circles. You don't have to be super accurate or anything. Right, cool. Right, so we're heading up, and the name of it is the angle between a tangent and a radius is 90 degrees. Right? Yeah, sure. All right. The angle between a tangent and a radius is 90 degrees. All right, is that a knock? What's in it, Jair? Jair, give them Jake one. Have a seat. Janaya, Javi. Right. So just two people, Janaya and Javi. Hopefully they come soon. Right. So the angle between tangent and radius, right? So this is okay, I won't bother to put that. One, two, three, four, five, six, seven, eight. So 4. Okay, cool. All right, so we have a circle and we have a center O. And we're going to put a line straight from the center to the circumference. What is the name of that line? A radius. That's correct. All right. So that is a radius, and we are going to join to this radius. Right. So the radius will be denoted by OT. And the green line is what we call a tangent. And we're going to call that tangent PQ. Hey, Ari, how you doing? Caribbean drinks, boy, vibes. All right, so let's get a couple definitions going here. All right, so a tangent is a straight line that touches a circle at one and only one point on the circumference. Right, so right, the green line PQ is a tangent to the circle. T is what we call the point of tangency. Right? OT is a radius. Right? And this, hold on, I think I'll put in a darker color. Let's put in a darker color. Why not? This one here. Right? And the angle between the radius and the tangent at that point of tangency is 90 degrees. Earlier, Priya, how are you all doing tonight? Right? So the angle OTP, right, is equal to 90 degrees. And you can go the next way, you can go OTQ. OTQ is equal to 90 degrees. Right? And that's the angle between the tangent and the radius. Right? So again, a tangent is a straight line that touches a circle at one and only one point on its circumference. That point here is point T. Right? Right? So PQ, the green line, is the tangent. It is the straight line that touches the circle at one and only one point. T is the point of tangency. OT is the radius, as you can see, it's a straight line coming from the center to the circumference. And at that point of tangency, the angle between the pink line, the radius, and the green line, the tangent, is 90 degrees. Right? Now, with the other theorems so far, the other rules, I showed you all proofs for most of them, right? This proof, when I read the book, it was something called reductio ad absurdum, which is proof by contradiction. And I never really got a handle on how to do it, but basically they assumed that it was 90 degrees and showed that it couldn't be anything else but 90. But I'm not sure how to do that, so I'm not going to try to show it, because then I don't know what I'm doing and I don't want to confuse you. Once again, you don't have to know the proofs, the syllabus does not require, but it's nice to know how and why these rules work the way they do. All right? Okay, so I'll give you a little brief run on what I have for today. I have a couple of examples lined up, right? So you're going to be drawing quite a few circles today, so make them small to medium, right? So I have a couple of examples, and I have question 1, question 2, question 3, and 4, and 5 lined up, right? So I have 5 questions thereafter, right? So we could spend most or all the time on the questions. If we finish a little earlier, we could actually start and preview the next set of stuff, which is where you have 2 tangents to a circle that originate at a common point. And that introduces some interesting symmetries and actually gives rise to the last rule, which talks about the angle between a tangent and a chord. Right? So a chord is another type of line inside a circle, but we'll come to that just now. Right, I'll scroll along to about here. All right. We'll get a little separator line going, and then we will check out the example. Now, with 90 degrees, right? What's the name of that kind of angle again? 90 degrees also called a right angle, right? So if we were to introduce a triangle like this, what kind of triangle would it be? A right angle triangle. And what do we call the name of this line here opposite the hypotenuse? And whose theorem do we associate with right angle triangles and hypotenuse? Pythagoras, right? Okay, good. And we also have scope for maybe sine, cosine, and tangent, but we won't be using sine, cosine, and tangent just yet. We're doing trigs from scratch in December, folks? All right. We're in November now, right? Yeah, today's what? The 6th. So almost a whole week gone in November. Look at that. As of tomorrow, and at the end of the day tomorrow, 1 week gone in November already. So, mind your P's and Q's and your X's and Y's. Because, I mean, we have 6 months until May 2025, eh? It fast approaches. Okay, so let's get a circle going here. All right. We'll expand a little bit. 1, 2, 3. Okay, I'm going to do one more. Right, so I can get a line. Okay, cool. Right, so in this particular case here, right, so we have O, center of the circle, right? We have, welcome the man, Philip. We have O to T and we have okay, I draw that out, sorry. Right, so that's O, that is T, that is A, right. So we have an angle, an unknown angle here of theta, and we have a marked angle of 50 degrees. So in this case, we have to find theta. Okay, so sorry, Livington. So is this circle theorem? Yes, it is circle theorem. That's correct. We're doing the angle between tangent and radius, right? Okay, so find theta. So let's zoom in a little bit here. Okay, so we gotta find theta now. What apart from this circle, what shape we see on the diagram here? A triangle. Now we have two out of the three angles in the triangle. Well, sorry, we have one and we're looking for the other one there, right? But what about this missing angle on top here? Do we know what that is? What is it? 90. Why? Because it is the angle between a tangent and a radius and a tangent, right? The radius being the straight line from center to circumference, and the tangent being the straight line that touches the circle at one point on the circumference. The rule we just learned said what? That the angle between tangent and radius is 90 degrees. Let's put that in as 90 degrees, shall we? Okay, cool. Let's state that, right? So find theta. So we could say that angle OTA is equal to 90 degrees because this is the angle between tangent and radius. Hey Cameron, how you doing? Long time no see. Okay, cool. And how will we find this unknown angle theta down at the bottom there? Theta would be equal to 180 minus 90 plus 50 degrees. 90 and 50 is 140. 140 from 180 is 40 degrees. Right? And we could add an extra little asterisk here because we have to explain where the 180 come from. Right? And the reason that we have this 180 minus those two is because angles in a triangle sum to 180. Is sum or add up to 180 degrees. That's example one. I'll do a second example one time. Oops, sorry. 1, 2, 3, 4, 5, 6. Right. Let's say we have a center O. Oh Lord, we're getting that happen now, boy. Okay. So we have this radius that is produced past the circumference, which I think is called I thought it was a secant line, but I think a secant line has to go straight through the circle. All right, so in this case, we have to find angle X. We have a 35-degree angle here. Oh, we need some more letters. Sorry, my bad. All right, so this point on the circumference is point A. This point out here is point B. And this point up here is point T. Right? And we have two things to find. So we have to find angle BOT and OAT. All right, so BOT is clearly angle X. All right, now apart from the circle, what shape are we seeing on the screen there? We're seeing a triangle. All right, in that triangle, do we have any of the angles? We have the 35-degree angle, and we're looking for the missing one. Can we figure out what this angle is on top here? What is it? 90 degrees. Why? Because the angle between tangent and radius is 90 degrees, right? Let's see if I can draw it a little better. Nope. Right, so we have that angle there, 90 degrees. So if you want, you could even start off by citing that. Now, you don't have to start off by citing that, right? But I will, just to kind of get it out of the way. So angle, so you could say OTB, so starting at O, going to T and going to B. Or you could say BTO, B to T to O. So the middle letter is usually the angle. So OTB, off-track betting, is equal to 90 degrees. And I could say this is because the angle between tangent and radius. All right. So if we go down a little bit, let's talk about BOT first, shall we? We put that one in pink because the angle in pink, right? So angle BOT, how will we find BOT given that we have 2 out of the 3 angles in the triangle? Correct. We add up the 2 angles that we have and subtract from 180. So BOT is equal to 180 minus 90 plus 35. Sorry, one sec. Right, 90 and 35 is 125. 125 from 180 is 55 degrees. Right? And again, we could explain the 180 because as angles in a triangle, sum to 180. So I put a little 1 there. Note 1. Angles in a triangle sum to 180. All right, Donovan, Jacob, and Melissa. Melissa, Khalifa, sorry. Are we okay what we have so far here? Any questions, anybody, anything? No? All right. Michael, Jaden, Noah. Are we okay with that stuff so far? All right, Nyla, Paige. Yes? No? Maybe? All right, Josiah, Shamor, Jaziri. We okay so far? Okay. All right, Aisha, D'Angelo, Jair, and Logan. My Google Me people. If you guys are good with that, just kindly give me a G in the chat if you need me to re-explain. Right? I want to say like the first 2 things thus far. Right? Hey Zahar, good evening. How you doing? All right. Okay. I'm gonna copy and paste the diagram, but y'all could draw in the line I'm gonna draw in on the same diagram you have, right? Copy. Paste. Oh crap. Already on 2 pages, so I might as well just go down then. That's fine. Okay, the next angle is OAT. Right? Now, angle OAT starts at O, goes to A, and goes to T. But we have no line connecting A and T. So what we're going to do, we're going to draw it in. And then angle OAT becomes this angle here. Let's call it Y for the sake of simplicity, right? Okay. Now, let's zoom in temporarily. Yeah, how are you doing? Right. Let's take off this as well here, right? Oops. All right, take off that, and we put this back. Okay, so tell me something. We went from having one triangle in the initial diagram to having how many triangles here technically? 2. You have the smaller one to the left-hand side of the orange line, and you have a bigger one to the right-hand side of the orange line. The angle that we're looking for, which side of that orange line is it on? Left side or right side? Left side. So it's in the triangle OAT. Now tell me something. OA, this line here, what do we call that line in the context of the circle? It is a radius. That's correct. What about OT? That is also a what? A radius. Oh. So we do have an isosceles triangle, which means what? Which means this angle on top of here is also going to be equal to Y. So if we had the angle here, sorry, wrong color. Let's put that in purple. If we had the angle here, we could solve for those two. But did we not just find BOT? Wasn't it 55? It's 55? Yeah. So how would we find? Right, so we could say B, sorry, not B, OAT. OAT is equal to 180 minus 55 divided by 2. 180 minus 55, I think, is 125. 125 divided by 2 is 62.5. Right. So I'm gonna put a hold on. Put a little 2 down here, right? So for the item 1, right? Rule 1 from above applies. Right, which is the angles in a triangle sum to 180. And rule number 2 is that base angles of an isosceles triangle are equal. Irony and Shivan evening. Becoming Carissa. Interesting name. Oh, thanks for liking live, Irony. Appreciate it. Okay, right. So you see what we did here in this particular case is we had to draw a line that was not initially given to us in the diagram. We had to draw it in to be able to find the angle that they want us to find. All right, okay. So I'll hold it there for a minute or two well, a couple seconds again, sorry. So you can copy down whatever you have to copy down. And then we'll switch to the next page and start the first question. Right, so yes, and please do write your rules. Again, we're trying to find ways to kind of cut down on how much writing we have to do. So I'm trying to number the rules when I use them, and maybe cite them again, So we don't have to write over any rules we've written before in the same question. Right? But you can't transfer them from question to question. As in, you can't cite in question 2 a rule from question 1. Right? Each question is independent. I mean, the rules don't change, to be honest. Eh? But still, you want to take that chance. Sorry. Right. Okay. All right, there we go. Okay, so the work has been taken from the Tool C, Volume 2. All right, so we're modifying the questions a little bit so they're not exact copies. Catherine Sedeno, evening. Any relation to McKelly? Would you? All right, so let's get this question going. Question 1. So we're going to be dealing with a circle. Well, hold on. Am I? Yeah, I am. 1, 2, 3, 4, 5, 6. Okay, cool. Right. So we have center O. All right. So we have to find the following angles. And there are 3. So find, in the first instance, angle BOT. Sorry, hold on. I forgot to put in we have an angle here of 16 degrees. My bad. Right, we have to find BOT. Then we have to find OAT, which might involve drawing in a line that's not currently there. And item 3, TAB. Right, and what's the rule we learned about today? The angle between a tangent and a radius is 90 degrees. So where would that be here? By T, that's correct. So let's mark it in one time, so and then cite the explanation so we could get on with life. All right, so rule number 1, angle. So you could say OTB or BTO, doesn't matter. All right, 90 degrees. Angle between we're getting circle geometry. We're exploring a new rule today, which is, when I say a new one that we didn't see before, right? Which is that the angle between a tangent and a radius is 90 degrees, right? So let me print out this page for you, right? Hey Nandita, how you doing? Good to have you on. Natasha, what vibes? Jada Weeder, I like that name. What standard? This is secondary school, so it's Form 5 actually, Natasha, not standard 1, 2, 3. So it's not SEA work, unfortunately. But there are some things you might be able to be able to do. Right? If you know about circles and triangles and angles, you might be able to do it. Right? Yeah, I hear you. I might have to do some streams for that boy. Good. Yeah. No. Yeah, I'm gonna click on this. There you go. Hey Angela, evening, how you doing? Right. Right. So rule one. The first rule we used was the new rule that the angle between tangent and radius is 90 degrees. All right, let's talk about BOT, shall we? So BOT is that angle there. All right, but give me one second. Let me actually copy and paste this diagram real quick. I'll need that for the next one. Right, so we're looking for this angle here. Right, so that angle exists in a triangle, and we have the other two angles. So how do we find that one? BOT. Yeah. Right. Mm-hmm. Right. Correct. Very good. Right, so the two rules we're going to cite here is we're going to cite rule one. Right, rule one applies. And then, so I'll put a little two here. So two angles in a triangle sum to 180. Sum to or add up to 180. Right, so we got 74 there. But the next angle they want is OAT. So OAT, you'd have to draw in a line. Actually, let me get a different color there. Yeah. OAT will be from there to there. So now we're looking for this angle here. Right? And we just found out the one in the center is 74, right? Right. So ask yourself if that triangle has anything special about it. Right? You can look back to the example we just did. That might give you a bit of a hint. You have it. I printed off here. Math the man book, yes? Right. So let's zoom in here for a second. So what can we say specifically about OA and OT? What kind of lines are those? Straight lines, yes, but in the context of the circle, what are they called? They're called radii. They're each a radius. And as we know, in any given circle, all radii have equal length, right? So that means that that triangle, OAT, is what type of triangle? Isosceles, which means that this angle across here is also going to be equal. So let's just call it small a, right? So both of those angles have the same magnitude. How will we therefore find the value of each of them? That's correct. Why 180? What does 180 have to do with it again? Correct. And why we divide them by 2? Because those two angles are equal. Sorry. What then? Part 2 is OAT. Right, so OAT will be equal to 180 minus 74, then divided by 2, right? So rule 1 was that, rule 2, right? So we'll cite rule 2 here again, right? And then we'll do a 3 down here. So 180 minus 74 is 106. 106 divided by 2 is indeed 53 degrees. Very good. Right? So you can see rule 2 applies, or rule 2 from above applies, but you don't want to use too many words because, again, you don't want to have to write the same thing over and over too many times. So rule 2 applies. And then 3 is that base angles of an isosceles triangle are equal. Okay, we have one more piece in this question here, all right? But let me just check in. So Donovan, Jaco, and Khalifa, not Melissa, are we okay with these 2 pieces so far? All right, Jaco and Dr. Mary, cool there so far? All right, cool. Mikel, Javier, Jayden, Noah. Yes, no, maybe? Yeah? All right, cool. Nyla, what page one? Okay, cool. All right, so there's really nothing. Josiah and Shamo, we good with that so far? Yeah. All right, and Google Meet. Just give me a quick G. So Aisha, D'Angelo, Jair, and Logan. If you're good with that, give me a quick G, and we move on to the next piece. We have one more piece in the same question to do. So I'm going to copy over the same diagram. All right, and last thing is TAB. Okay, cool. So TAB will be this angle here. Take off this piece. Take off that. Any ideas? Let me hear you. Uh-huh. Okay, so you have this whole 90, that's 53, so you're subtracting that piece to get this piece here. All right, cool. And then what are you doing with that? You're adding that to 60, and then that's correct, you could do that. Anybody could see a different way to work it? What kind of line is this? And what's the angle on a straight line? So if we have 53 here, could we not just subtract that from 180 and find TAB? Right. But it's still good to know different ways to work it, yeah? So TAB would simply be equal to 180 minus 53, which is equal to 127 degrees. Let's cross check it. So Ashimo was saying this is 90. If you subtract your 53 from the 90, you get 37. 53 from all right. 37 and 16 is 53. And 53 from 180 is the same 127. Right? And the rule here for rule is the angle on a straight line is equal to 180 degrees. Right. So again, as we can see, there are different ways you could go about finding the same correct answer. No one way is more correct or less correct than the other. They're all equally valid. Sometimes, however, one might be a bit more efficient than the other. So with Shimo's one, you had, I think, 1 and 2 sets of working to do. Here you had 1 set of working to do. Right? But sometimes, sometimes we can't see certain things. So once you can see it, organize. Okay. Sorry. All right. We're still copying wrong stuff. No. Okay, cool. All right. Let me know when you're ready, right? Good to go? All right, cool. Question 2. 1, 2, 3. All right, cool. That one is fine. Right here. So we have a circle here with center O. Sorry. Right, so O is produced to point B, and then from point B, we have a tangent that touches the circle at point T. We have a point A on the outside here. We are given the magnitude of the angle at center being 70 degrees, and then we are being asked to find the following angles. Right, so we have to find the following. OBT, which we'll call small x. Then we have to find OTA, which we'll call small y. And then we have to find ATB, which we'll call small z. All right.
Moving also straight line. You have y already. So with the straight line, so subtract y to
All right. So at the outset, so what was the rule we learned about today? Yeah. Between radius is 90 degrees. So the tangent is here, radius is here. So our 90-degree angle is here. Right. So OTB is equal to 90 degrees. And this is between angle between tangent and radius. Right, this is a shorthand for angle. I know it looks like a less than sign, but the bottom piece runs flat on the line, right? Okay, so let's talk about item 1. OBT. So OBT is that angle there. One second, eh? Right, so to find this angle, which we call X, how will we go about doing that? Anybody? Right, so X exists in the right angle triangle, and the sum of the angles in a triangle is 180, right? So OBT all right, so OBT angle OBT will be equal to 180 minus 90 plus 70, yeah? Right, so that's rule 1, that's the second rule we're going to cite. 90 and 70 is 160. 160 from 180 will leave us with 20 degrees, right? So rule 1 applies. Right, and the second rule is that the angles in a triangle sum to 180. All right, now we want OTA. OTA, let's see if you have that now. So OTA will require that a line be drawn from T to A. And OTA, hold on, yeah, OTA would be this angle here. Y. All right, what do we know about this triangle inside the circle here? It's isosceles, right? Because this side and this side are both radii, and all radii in a given circle are equal in length. Hence, you have an isosceles triangle, which means that this angle across here would also be equal to y. Right, so to solve for that value, what we do, we would take 180 and do what? Take 70 from 180 and then divide by 2. Right, so this is rule 2 again. And we'll do a third rule here. So 180 minus 70 is 110, and 120 divided by 2 will give us 55 degrees. Right. Right, so we could say rule 2 applies. And 3 base angles of an isosceles triangle equal, yeah? All right. One more piece to this question. So let's put the diagram back again. Cool. Right. ATB. Oh no. I want that angle. So AT. So let's put back the purple line, shall we? All right, so ATB is actually this angle here. Right, now unlike the previous question where they wanted us to find this angle here, and all we had to do was subtract the other piece from 180, right? Here we can't do that because the other side is what? Well, that's 90. That's 90 here, not so? And we just found that this piece, the piece on top was what, 55? So all we have to do to find Z is what? 90 minus 55. That's correct, 35 degrees. Uh-huh. What you're just going to do, take 55 from 180 to get this piece, and then we add that from above, and then add those two and subtract from 180. You could do that too, right? So it was 55, right? The 55 from it is 125. 125 plus the 20 is 145. And 145 from 180 is 35 degrees. Yeah. Uh-huh. Right. Yeah. Yeah, that's it. Yeah, that's correct. All right, no problems. Right. Questions? Anybody? Anything? This shit in the picture behind it. It's leaning this way. This on on the bottom right hand side. Yeah, yeah, that it. Thank you. Oh, look at it. Yeah. Well, something might be missing next week when you come back, but we'll see about that now. Huh? Something. Wait, so after all that is still working? What was the point? All right. All right. Aisha, D'Angelo, Jair, and Logan. Just give me a quick genie shot to figure with this question, please. All right. If you need me to reaction, give me a R. All right. Oh, I get all four. Boy, what? Feeling like a bite of shilling. Okay, going again. A4 page 4. Those are the 2, 3, 4. So we will. J. Hugh boy, what's going on? Okay, so let's go. All right. Well, is it a pink here? Is it a green here? Maybe we could do a blue on this one. All right, so we have a diameter. And they close this up here. Right, so let's get some of the other letters for the vertices going. Well, maybe not vertices, but points. So that's point A there. That's point B there. That's point T. And that's point C. And they've given us one marked angle down here, which is 27 degrees. Put it in a slightly heavier weight. Right, we have just two angles to find in this question, so find one. Yeah. All right, we call this one X. Call this one Y. So I'll give you guys a few minutes to sort that out. All right, so drawing a diagram. All right, identify where it is the angles are that they want you to find.
So this is going to be 90 degrees. So I'm going to find out. Just going to take away the sound here from my so you find the sound yeah. So just whatever you get what you're saying because these two are here. You gonna get? Yeah.
What was the explanation for OCT?
I think you found X, which was 63. So you're gonna take away the 63 from the 90. Because this whole, these two things together are already 90 degrees. Wait, which one? Oh, shit. So you'll take over, yeah. So then you could find, look, that's how I would have it. Well, that's not really right. From 180. So you found this one. Subtract that answer from 90. Oh, I thought you said I had 270. But yeah, sorry. Well, let's not just use okay, so we find X. Or do you want to go there? Okay, cool. Okay, so. To find X, I understood that. Okay, so there are 180 degrees. So you're gonna this is well, subtract this. You're gonna subtract this and this and then subtract so when you get that, you're at 63. Yeah, because of that. Just y. You're gonna okay, so you call access. You're gonna subtract that on there. See that 63. Doesn't make any because it's on a straight line. Is that close enough?
It was.
Yeah, so you found X already. It's on a straight line in front of us. So once you subtract that, 126. So when you find this answer, you're gonna subtract it from what we got here. Okay, that's okay.
You don't have to write on. No, the reason it is because OCT, C is in the C is where you are. Yeah, that's the issue. That's the O. That's why you are.
all 170. So that's supposed to be an angle after. So that's find that answer. Does that make sense?
Yes, so. I was
Alright, folks, sorry. There's a puppy that's in that class.
That's why.
Alright. Alright, let me see. I feel like it have hurt. I feel like it have some. I don't see any reasons written in anybody book. Okay, you did. Yeah, sorry, Amanda. I did. Sorry. I went to check the other class for a second. Thanks for the reminder. Alright, ladies and gents, let's take a look and see what's going on here now. So first things first, what's the rule we learned about today? Angle between tangent and radius is 90 degrees. That's tangent, that's radius, that's 90 degrees. So let's cite that at the outset. So reason one is that angle OTB is equal to 90 degrees because angle between tangent and radius is 90 degrees. So angle between tangent and radius. Okay, cool. So now to find BOT, how are we going to do that? That's this angle here, right? Okay, well, that exists in a triangle. What's the sum of all the angles in a triangle? And do we have any of the other angles in that triangle? 27 and 90. Right, so therefore, for item 1, BOT. So what would the working be? That would be equal to? Right. Very good. Right, so what we call this? This is rule 1 here. Call our rule 2. So rule 1 applies. And then 2 is that the angles in a triangle sum to 180. Right. And to find OCT, where is OCT? OCT is here. Right? That's in the second, smaller triangle. But what do we know about that triangle? We know that OC, hold on, this line here is a radius, and this line here is a radius. And all radii in a given circle are equal in length. So if you build a triangle using 2D radii, what kind of triangle is it? Isosceles triangle, which means that we also have the same magnitude across here. So this is y and this is y. So if we had this angle here, we could conceivably find angle y, not so? And tell me something, isn't that a straight line that is on? And the angle on a straight line is 180 degrees. And since we have angle x on this side, how do you find the other angle on the other side? 180 minus x. Correct. So 180 minus 63. Right. Let me see where. From 180. No. When you take away the 163, sorry, the 63 from that, this is 117 here, right? And you have to subtract that from 180 and divide that by 2 to get the angle Y. Well, nope. That's 63 here, right? The pink angle. You're trying to find this angle. Yeah. Oh.
Sorry, guys.
Sorry, I got a little lost. Right. Okay. So we're trying to find OCT. So OCT would be equal to 180 minus the 117. We'll put that as what? As 3. And divide by 2. So 63 divided by 2. Very good. And there's 4 down here. Right? And this is rule 2 here. Right? So rule 2 applies. Rule 3, the angle on a straight line is equal to 180 degrees. Page, all right? And then base angles of an isosceles triangle are equal. Okay, Google Meet, just give me a quick Genie chat if you guys good with that. If you need me to re-explain anything or everything, let me know. It's not a problem. G is the barber boy. Alright, D'Angelo, Logan, Aisha. What about Jerry boy? Alright, Khalifa, Jaquan, and Donovan, how we feel with this question here? Any questions? Anyone to re-explain or we good? Good? Alright. Mikhail, Xavier, Jaden, Noah, are we okay with this one here? Any questions, anything? No? Alright, cool. Paige, Nyla. Oh. Hanifa, they gave me 500. Right, oh, but 5, how come 5? No, sorry. No, it's 5. Yeah, sorry. I'm mixing it up with my accounts class, sorry. Yeah. Okay, so next week then, right? Okay, bye. Oh, thanks, Ritz. Sorry, yeah. Josiah, Jaziri, and Shamal, we okay with that item there on the screen? We get through everything or you're taking a break? Okay, cool.
And then I'm gonna go home and spend another 5 hours on it.
5?
5.
Why 5?
So I have to make all of this into a 1,000-word essay, not 1,000 words, not including what I'm getting right now.
Okay. All right, there you go. All right, we have 2 more questions. Let's see if we can get them done quickly. Anybody still copying anything now? Okay. Okay, Kadisha, we'll see you next week, yeah? Day 4 page. Nope. Funf. Right. Right, we're gonna find BCT, which you could call X if you want, and COT, which you could call Y. If 31 is one of the answers. Not that I can see here. So first of all, BCT is this angle on top of here. And C. That's right. For BCT, 5. Yeah, well, if it was 5 and a 3-digit number, that might be a problem. And it started with it, yeah, so 50 something. Yeah. Yeah. Hey, Haley, I'll see you tomorrow, right? Okay. Okay, Salome. All right, sir. Bye bye. All right. About who? Right. Maths? Oh, wow. Yeah. If they want to, usually for exam they stop, but I told my class I just doing syllabus work, so if they miss, they're gonna check out the replay. But message the parents. Tell the parents you would prefer to continue because we have syllabus to cover what you understand, but you need to know, right? You leave it up to them. Yeah. True. I told her mama we hadn't seen her for October until the first day, and she was very sure she came the previous week, but I was like, once, yeah, like first or something. Well, her brother there, so we can ask him. Yeah. 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 That's the reason on some funds are coming. People taking long to remit. Yeah, I hear you. You what? Manure. Okay, yeah. Oh, wow. I'd ask me the same question too. Holy cow. What is he feeding? Right. What it is you testing? So it is a significant amount of methane that could have what an environmental impact. Or you could. Yeah. Right. Yeah, I don't know. Horses. Yeah, actually, that was a reason. Cows, we know, was a big one. But I know in New York City, back in the day, they actually had to ban. I think they had to ban horses from coming down thing because they were just shit all over the place. What for horses? Oh, yeah. Well, I know the veterinary school might have horses. Yeah. Yeah, dress appropriately. Your boots and gloves. Yeah. Okay. That sounds serious. Yeah. Yeah, well, yeah. The name of science.
Yeah. Well, do you want me to take over for you? Okay, cool. That's okay. I'll just have to confirm it's two of them.
Maybe three. There's actually three, but one girl hasn't come for the whole of October. That's actually Josiah's sister, so you could always ask him what you know. 29.5. I will check it just now.
Yeah, I don't mind. I'll just have to confirm right now.
Paul's Cloud. Let's check it.
Sounds good.
My supervisor goes back to Germany on Monday,
Uh-huh.
and I will have zero stress. I will not have to come into.
Uh-huh. For sure. Right. Yeah. Okay. Oh wow. Next week? Or okay. Okay. That is the 16th, I think. Okay. Wow. What was that? You could fit more into it. You get momentum going. All right. Next week? Okay, cool. Huh? Yeah, we went. Yeah, we went doctor today just for a little checkup. He good. He's good. Shiloh have a little cough, so we got some little nose drops in because it's the congestion causing the coughing. Yeah, yeah, you good. Yeah. Okay. Yeah. All right. Later. Yeah, Jake, can talk to me. You got it? Yeah. Define X. Yeah. Yeah. That's correct. Well, I found y first. The end up being easier to find first. And then I found x after. Oh. Okay, no problem.
I'll message you tonight to confirm that we'll come back to one.
Yeah, all right.
Okay, see you.
Okay, later.
Bye guys.
Yeah. Yeah, so close 29.5, correct. All right. Uh-huh. One more to go earlier, but yeah. So you're saying, Jaden, move that line.
Yeah, I think I removed that line. I did the triangle, it's a BC. But what I was gonna ask is, because we moved that line, the 90 degree, is a good
Well, the 90 degree,
50.
yeah, well, that wouldn't be 90. Because the 90 is only between those two lines there. But then you see, if you take out that line, you only have one angle in the triangle.
Yes, I think that was.
So yeah. All right. Okay. Let me just see. Yo. Talk to me.
I didn't know where you signed from.
See, COT, angle COT, and then BCT. BCT is that angle X there. You could also call that OCT if you want, or TCO. Correct. Oh, okay. Understood. All right. Yeah. All right. BCT, that was the 29.5. Yo. Yeah, good. COT, that's the Y, that's the first one. Sorry. Yeah, 5 minutes. And then BCT is down here. All right, this one, we will do it quick. All right, well, that's good. All right, do overthink this one. It's easy. Calls Cloud. I'm using Microsoft OneNote. It's part of the Office 365 subscription. 144. It is? Yeah, because OT and OA are radii, right? So that is 18 degrees. And this is a 90 here, right? Yep. Right? So like I said, don't overthink it, yeah. Alright, folks. We'll put a pin in it there for today. When we come back on Monday, we're going to be taking a look at where we have two tangents to a circle. Huh? Yeah, it have a few interesting observations we'll make. Alright? Anyhow, so if anybody has any questions and they get to after in class, please feel free to message me. We'll do it. I'll see you on the next time. I'll go on there. Bye.